Hello, ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 1 course. Today we're going over section 3.1, which is graphing and writing inequalities. So before we can start graphing and writing inequalities, we have to begin with our definitions, because if we don't know our definitions, then we don't know what we're talking about. So today our first definition is inequality. An inequality, if I can write inequality, an inequality is an equation that uses an inequality sign. So inequality signs come in four forms. You have less than or equal to, greater than or equal to. And the way we look at these is if you think of two numbers next to each other, let's say 4 and 8, right? 4 is less than 8. And the easy way to remember which way the less than sign goes is if you turn it into Pac-Man with vicious fangs, Pac-Man will always go towards the bigger number. So Pac-Man would go away from the 4 because it is less than 8. So you would say 4 is less than 8. And then we have something like 4 and 4. Well, with 4, they're equal to each other, and normally we would say that would be fine. But in truth, we could say that 4 is less than or equal to 4 because they are equal. You can say less than or equal to. Or you can say 4 is greater than or equal to 4 because they're both equal. So when they're equal, it doesn't matter which way the Pac-Man sign goes as long as you have this bar underneath it. So let's go ahead and label these guys as less than or equal to, greater than, and the last one would be greater than or equal to. So there are 4 inequality signs, and an inequality is just like an equation, except that we use inequality signs. Alright, so let's go on and see if we can't find an example and then learn how to graph these guys. So let's look at a really simple example. Let's pretend that our example says that x is greater than or equal to 4. So in this case, we're saying all numbers that are greater than or equal to 4. So what would be a solution to this inequality? Well, we could always say the number 4, right? Because if I plug in 4, let's see, plug in here, we get 4 is greater than or equal to 4. And because it says or equal to, this creates a true statement. What about 5? Is 5 greater than or equal to 4? Well, yes, 5 is greater than 4, so it will work out. What about 6? Well, 6 is greater than or equal to 4. 7, 8, 8 and a half, 8 and a quarter, 8 and 3/4. All kinds of numbers are greater than or equal to 4. So the real question is, how do we show this? Well, we show this using a graph, a single number line graph, not the Cartesian coordinate system that we're used to working with. And in the middle, we'll pick a number. I usually like going with whatever number is here for the number that I pick to be right in the middle, so I'm going to put a 4 underneath that. That means this tick mark is 4. And now I am looking for all the numbers that are bigger than 4. We already tested 5 and found it's bigger than 4. We've already tested 6 and found it's bigger than 4. So I know I need to include these numbers. The question is, how do I show that? Well, I show it with a ray. So with my ray, I start at 4 and I go to the right because I know that 5 was a true statement and 6 was a true statement when I plugged them in. But what about at 4 itself? Well, at 4 we have a bar underneath. This bar represents that we are solid. If you have ever been hit by a bar, you know those things are pretty darn solid, and it hurts. Some would say it even megahertz. So we put our dot at 4 as a solid dot to say that we include 4. So for a rule of thumb here, if you have a bar, then it's a solid dot. And if you don't have a bar, well, let's look at another case. Let's say that we have x is greater than 4. In this case, is 4 greater than 4? Well, the answer to that question is no, they're equal to each other. 4 cannot be greater than itself. It has to be equal to itself. If we had the bar underneath, it would create a true statement because then they're equal to, we can include it. But if we don't have that bar, we can't include that number. So when we're graphing this one on our number line, once again, it's good to start at the number that you're told to, 4. And now we know that we have to be greater than 4, which includes all the things to the right. So it's very similar to a previous ray. The thing is, there's no bar. So how do we show that there is not a point there? We use an empty circle. If you have a bar, you're solid. If you don't have a bar, then it's a circle. It's open. If you don't have a bar, then use an open circle. And let's make sure that this apostrophe T looks a little bit better. All right, so if we have a bar, it's solid. If we don't have a bar, it's empty. Now let's look at another example. Let's say that we have 4 is less than or equal to x. Well, once again, we have our number line. We have a bar, so we know we're going to be solid at 4. But then which way do we go? Do we go to the left or do we go to the right? Well, since we're saying that, oops, I made my inequality sign backwards here. If we're saying that 4 is greater than x, if I plug in 5 for x, then I would have 4, if I can ever write today, I would have 4 is greater than or equal to 5. Now, is this a true statement? No, it is not a true statement. So, to know which way you're going, plug in a test point. And for this one, it's a really easy saying. If true, then through. If false, flee. So when we plugged in our 5, which is right here on our number sign, it proved something that was false. It gave us a false indicator saying that 4 is bigger than 5, and we all know better than that. So since it's false, I don't go through that point. In fact, I flee from it. So I go in the other direction of that point, which would be to the left. If true, then through. If false, flee. All right. And now let's go ahead and see a real-world application of this. Something that you see quite often, especially in horse racing. Hey. for all those horse people out there, they know that their horse and saddle and rider have to be within a certain weight range. They know that their rider must be over 160 pounds. So how do we show that mathematically? How do we show that our rider must be over 160 pounds? Well, we would say that our rider's weight would be a variable. It would be x. And that x has to be related to 160 in some method. Now the key word here is over. If it says that we have to be over 160, then is 161 pounds over 160? The answer to that question is yes. Yes, it is. So I know that my x has to be greater than my given value. But does it say that it has to be equal to? Well, if it says the rider must be over 160 pounds, that kind of leaves it in an ambiguous case. However, we can always assume and go on the side of caution and say that it doesn't mean equal to. If you have to be over 160 pounds, then 160.1 pounds would be good enough, but 159.999 would not. So 160 has to be, or x has to be greater than 160 pounds because that's what over means. Now, how about for doing something like playing on a swing? Or sitting in a chair. So let's say that we have a chair. To sit in this chair, let's write this down. To sit in this chair, the person must be at most 350 pounds. So this is really math and easy. This is like legal speak, right? With the term at most. Well, at most means that's the maximum value, meaning that you can be that value but no bigger. So if I have a person and they want to sit in this chair, what must they be? Well, it says at most 350 pounds. So as long as they are less than 350 pounds, we're okay. And with the at most, you can kind of say, well, that's going to be equal to as well. So we're going to say x is less than or equal to 350 pounds. And then using our graph, we would, of course, put 350 in the middle. And then since it's a solid, we make a dot. And then I have to ask the question, if I plug in 100 for x, which is like way over here, is 100 less than or equal to 350? The answer to that question is yes, 100 is less than 350. So if true, go through. All right, ladies and gentlemen, that is it for today's lesson. I hope you have been a very good audience and didn't make me too angry while you were in class. But that's okay because life is as it is. So here is your favorite part. Here is your homework assignment. Yeah, I can't speak today. Your homework assignment. And your homework is going to be section 3.1. Hashtags. And we're going to go through 1 through 17 odd. And then we're going to grab some other ones from other locations like 21, 23, 25, 27, 29, 31, then 33, because that deals with work and is important, 37, 43 and 45, and just to make your lives more fun, let's go with 49, 51, and 53. So for this one, and for all homeworks from this point forward, no work, no credit. If I do not see your work for the homework, you are getting no credit for it from this day forward. All right, good luck and have fun.